Okay, Common Core Algebra 2. We are on to our next section in Chapter 5. This is going to be 5.4, Part 1, and it's going to be about factoring polynomials. Okay, so one thing we're going to do is factoring quadratics, and this will just be a review, and these are going to have 3 terms, more or less. And so we're going to call them trinomials, obviously. And then we're going to talk about a GCF, which is a greatest common factor. And then the last one is how to factor by grouping, which you've actually seen before, but we never actually probably identified it with those key terms. Okay, so a quick review. Factoring trinomials. We looked at 2. One when a was equal to 1, and one when we said a was not equal to 1. So when a equals 1, it's really like that's just a 1. So we had things that look like x squared plus bx plus c. And we did this back in the first semester. Okay, and it's the reverse of FOIL, if you've heard that term before. Again, we didn't really use that term, but a lot of math teachers I know do. And finally, what we're trying to do is find the factors of c that sum to b. So you'll notice c is your constant term, and b is only the coefficient of that middle x term. Okay, and you're going to rewrite it as 2 binomials. So this was the one that was pretty quick. And so c here is equal to negative 10, and we want factors of negative 10 that add up to positive 3. So we could go through, and remember on your calculators you can create a table or a list of values. I know that it's going to be 5 and negative 2 because you multiply those together, we get negative 10. You add those together and you get 3. So we could factor this. Remember, we want to write it as a product of 2 binomials. Binomials meaning 2 terms. A product meaning you're multiplying those 2. And so we're going to have x plus 5 and x minus 2. And if we multiplied these back together, we'd end up with this. Okay, so remember, factoring is the opposite of multiplication. Factoring is division. It's like the opposite of distribution. So that was when a is equal to 1. When a is not equal to 1, we still have that form, same form, but now a is not 1, obviously. Again, the opposite of FOIL. And this time, big change here. Now we're looking for the factors of AC that sum up to b. And we're going to use those 2 factors to rewrite the trinomial. Big piece here as 4 terms, and then finally that's going to become our factor by grouping. So our example here, 8 times negative 2. So AC is going to give us a negative 16 because that will be 8 times negative 2. And we want it to add up to negative 15. So we could go through that big list again. I know that negative 16 and 1 work because negative 16 times 1 is negative 16, and they add up to that. So I'm going to rewrite it as 4 terms. Remember, I'm only changing that middle term right there. So 8x squared minus 16x plus 1x minus 2. And it doesn't matter which order I write these in. And then I'm going to do factor by grouping, meaning I'm going to put these first 2 terms together and the last 2 terms together. And now I'm going to do greatest common factor. So I'm going to factor out what both of these are divisible by, which in this case is an 8x, and is going to leave me with a 1x minus 2, plus, since there's not really anything in common here, I'm going to factor out a 1, which leaves me as a 1x minus 2. And remember, this is good. We want these 2 to be the same. Okay, so my first term, or my first binomial, is 1x minus 2. And then my other term becomes whatever we have outside, the 8x and the plus 1. So then that would be the factors of that trinomial that we started with, okay, that quadratic trinomial. So greatest common factor, what you're going to do here, and we've already basically done this, we just haven't identified the terms, is you're looking for the highest degree of your exponent and factor of the coefficient that divides each term. So we want the greatest common factor, remember. And then this is the opposite of distribution, so basically you're going to divide. Now I look at 18 and 27, and I know that they are both divisible by 9, and 9 is the largest value they're both divisible by. And then I look at my variables, my x's, and I see this one is an x cubed, that's an x squared, which means the highest degree they have in common is an x squared. Okay, and you can think, remember this is the opposite of distribution. Distribution is multiplication, which means this is division. And so I'm going to say 18 divided by 9 is 2. X cubed divided by x squared is an x, so I get 2x left in that first one. 27 divided by 9 is 3, and x squared divided by x squared is nothing, so we just, or 1, so we just have the 3 left. This would be factoring based off of a greatest common factor. Okay, the last one then is factor by grouping, which basically we already did this. We're going to group terms with a common factor, so kind of like we had in the last one. And then we're going to factor out the greatest common factor, like we just saw in that last one, to create identical remaining terms. This is basically like we did with the trinomial when we created 4 terms. So you'll hear other teachers call it about like creating a squiggly there. So we're going to factor by grouping, meaning I am going to group my first 2 terms together, plus I'm going to group my second 2 terms together. And then I'm going to factor the greatest common factor out of each group, ignoring the other one. So here, the biggest common factor, the greatest common factor they have is an x squared, which leaves me with an x plus 4 left, plus, in that second one, they don't both have x's, so I can't pull out an x, but they are both divisible by 3. So 3x divided by 3 leaves me with x, plus 12 divided by 3 leaves me with 4. And same idea, whatever we have inside our parentheses has to be the same. And since it is, I can rewrite them as my first binomial. So x plus 4 is the first binomial, and the second binomial is whatever we have outside. So x squared plus 3. And this is a completely factored polynomial, factor by grouping. Sometimes, depending on what we get in here, we could have to factor one more step. We don't in this case, though. Okay, so that is it for factoring. We reviewed quadratics. Remember, that is an x squared term, and we did it when a was 1 and when a was not equal to 1. This one basically used those 2 types, the greatest common factor and the grouping. So if you can do when a is not equal to 1, you basically already are doing a greatest common factor type of factoring problem, and you are doing a grouping or a factor by grouping kind of problem. Okay, biggest thing with factor by grouping is that we need to have 4 terms here. Okay, and that factoring, remember, is division. Okay, and that's all we're trying to do. See you next time, guys.